Okay, we're in 3.1 and we're going to deal with graphs of linear equations. So graphs and applications of linear equations, first thing you do is you're going to plot the points associated with the ordered pair, determine the quadrant in which the point lies in. We're going to find the coordinates of a point on a graph. We're going to determine whether an ordered pair is a solution of an equation of two variables. We're going to graph linear equations in two different types, y equals mx plus b, and then standard, which is ax plus by equals c. And then we're going to do applied problems involving graphs of linear equations. So the first thing, and I hope y'all are familiar with this or you remember everything that you're supposed to. To graph or plot points, we use two perpendicular lines called an axis, or axes. The point at which the axes cross is called the origin. Arrows on the axes indicate a positive direction. Consider the ordered pair 2, 3. The numbers in such a pair are called coordinates. The first coordinate in this case is 2 and the second one is called 3. Or the second coordinate is. Okay, to plot the point 2, 3, we start at the origin and we move two units on the horizontal direction. Because 2 is positive, we're going to move in the positive direction this way, 2 places. So here's 1 and here's 2. The second number is 3, and because it's positive, we're going to move in the positive direction from that 2. We're not starting over, and then we're going to move 3 units up. And that is the spot you make a dot. Luckily, they already did that for us. So now we're going to plot negative 4, 3. The first thing we're going to do is we're going to start at the origin, and then we're going to move to the negative direction at negative 4. And then we're going to go up 3, and that is where we'll make our dot, is right there. And let's see if I can do it. Sometimes I'm off a little bit because of the ink. So it's negative 4, 3. Now, when you're working with a horizontal and vertical axis, you're going to divide the plane into 4 regions, or quadrants, quad meaning 4. So when you start looking at the quadrants, notice that it's in counterclockwise order. Or if I'll take it and draw like a C, so I'll know which direction to start. So that C kind of helps me make sure I know where things go. I'm going to erase it so that we can look at some other stuff. So it says, in which quadrant is 3, negative 4? So we start with our origin, and we're going to go over positive 3, and then we're going to go down to negative 4. And it's going to be right in this area. So that would be in quadrant 4. And notice that it is written with with Roman numerals. And that's what you need to continue doing, is Roman numerals. In which quadrant is negative 3, negative 4? So I'm going to start here. I'm going to go over negative 3. And I'm going to go down to negative 4. And it is in the third quadrant. The other thing that you need to notice about these, and make sure that you notice, if I go over positive and I go up positive, both of our ordered pairs, or all of our ordered pairs that falls in this quadrant not on an axis, is positive. In this one, the x value, the first coordinate, is negative, and the second one, the y coordinate, is positive. In the third quadrant, both are negative, and in the fourth quadrant, the x is positive and the y is negative. So now we're going to try to plot these, or actually they're plotted for us. We're going to write down the coordinates. So the first thing I'm going to do is I'm going to start with the origin, and I'm going to go over to 5, and I'm going to go up to 3, and that tells me A. So A is 3, 5. Stop the tape and you do this and see how it works for you. Okay, for B, I have negative 2, 4. For C, I have -3, -4. For D, I have 3, -2. For E, I have 2, +3. For F, I have -3, 0. And for G, I have 0, 2. How'd you do? If you didn't do well, you need to take a little bit of time and work on those. All right, now, the next problem says to determine whether each of the following pairs is a solution of the equation 4y plus 3x equals 18. So basically, you just plug in. This is your x value. This is your y value. So you're doing substitution. So 4 times 2, oops, sorry, got it backwards, times 3, plus 3 times 2 equals 18. So I have 12 plus 6 equals 18. 18 equals 18. So this is true. So this ordered pair would be yes. It is a solution. So now we're going to do the second one and using the same equation. So I'm going to plug in 5 for y and then 1 for 3, and let's see what we get now. So 4 times 5 is 20, 3 times 1 is 3, so I get 23 equals 18. It does not. This is false. So this would be no. This is not a solution. The graph of an equation is a drawing that represents all of its solutions. To graph a linear equation, we're going to select a value for one variable and calculate the corresponding value of the other value. And that will create an ordered pair. We're going to repeat steps 1 to obtain at least 2 other ordered pairs. So you want 3 numbers, okay? A third ordered point serves as a check. That's why you want 3 points. Plot the ordered pairs, draw a straight line that passes through. So we're going to put that. So we're going to find some solution to the ordered pair. We're going to choose any number for x, and then we're going to determine, then we're going to determine by substitution. So it's sort of like the t-chart or the y-chart. So I usually start at 0 for one number, and then I do 2 on the other side of 0 and 2 on the other side of 0. So really that gives me 5 plots, and it just works better for me that way. So I create what's considered a t-chart. So I'm going to plug in for x, and then we're going to see what we get for y. So if I do 0, I'm going to do -1, -2, +1, +2. So we're just going to plug in, and you may have to work this out on your own a little bit. So y equals 3 times -2, so y equals -6. Then y equals 3 times -1, that gives me y equals -3. Y equals 3 times 0, which is 0. Then y equals 3 times 1, so y equals 1. I'm sorry, y equals 3, +3. And then y equals 3 times 2, so y equals 6. Make that a little bit better. So now we just go in and we're going to plot these and see how it works out. Because we create an ordered pair. Let's look at our ordered pair. So we get -2, 6. Get -1, -3. We get 0, 0. We get +1, +3, and +2, +6. So then we just go over and then we're going to plot the points. So the first thing I'm going to do is I'm going to go -2, -6. then -1, -3, then 0, 0, then +1, +3, then 2, 6. Now for me to connect on here, sometimes it's going to be a little off because of trying to draw on my iPad, but that's pretty close. So that's all we do. You just plot and you graph and you connect the dots. This was an extra slide. I forgot I put it in there so we'd have some room. Now I'll remember. Okay, the first thing we're going to do is we're going to do this one. We're going to create a T-chart and get us some ordered pairs, and then we're going to do some graphing. So in this one, you can start anywhere you want to. It just really said, do you remember on the other directions it just said 3 points? So it's up to you what you want to do. So let's start with, let's create a T-chart. So let's let x be 2, 0, -2. And then we're going to work it out and see what we get. So y equals -4 times +2 plus 1. So we get -8 plus 1 equals -7. So our first order pair is +2, -7. So let's try 0. And again, you can choose any of the numbers you want to choose to see what happens. And you can plot them. There's going to be some tricks that you'll learn if you deal with fractions, because you want it to be a multiple of that fraction to make it kind of clear up a little bit. So we get +8 plus 1 equals 9. So here's our ordered pair, so we're going to go plot them. And here's our graph on this one. And lucky for us, the graph was already plotted for me, so that makes it a little bit easier. So all I have to do is just kind of connect the lines, or the dots. Let's see if we can do that a little bit. There's 1, there's 2. All 3 kind of connected. You will be able to do a little bit better. Now, y-intercept. The graph of the equation y equals mx plus b passes through the y-intercept 0b. What that means is it's going to cross the y-axis. Okay, the y-axis. Where b is, it's going to cross the y-axis. So for an example, if we were to graph this one, you would need to create a table of values just like we did before, and then we're going to try to graph it. We're going to check a couple of different things. Now, if you were to choose, because it's 1/4, and I want that fraction to go away, multiply it by some multiple of 4 that would make that clear up. And you remember, you only need 2 numbers. So if we say we let x be +4, 0, and -4, that should clear it up. So if I say y equals 1/4 times 4 plus 3, I get y equals, remember 4 over 4, or we drop a 1 up under here, these 4's are going to cancel, so you get 1, plus 3, so y equals 4. So our first point is 4, 4. Then we're going to plug in for 0, so y equals 4 times 0 plus 3, so y equals 3. So our next point is 0, 3. And then we're going to plug in for -4. Y equals 1/4 times -4 over 1 plus 3. Now be careful, you have this negative here, so that gives you a -1 plus 3, so that's going to give you a +2. So our other graph point over here is -4 and +2. And our graph has already been graphed for us. Made it a little easier. We didn't have to draw the line. Now notice where it crosses the y-axis right here. Crosses at 3. That is the y-intercept. That is where it crosses the y-axis. And did you notice that this was really not a coincidence that this is a 3 when it's written in y equals mx plus b form? We can tell where it's supposed to cross the y-axis. So we're going to talk about that more later on. Okay, to identify the y-intercept, in other words, you're going to go try to find it and see what it is. You need to put the equation into y equals mx plus b because you're trying to get it, the y by itself, so that we can find out where it's going to cross it. Okay, so we have 2y plus 3x equals 0. I'm going to subtract 3x from both sides. So I get 2y equals negative 3x plus 0. You can take the 0 off or you can leave it. Divide by 2. So see, it's just going to go away again. So we have y equals negative 3x over 2. Now, did that tell you where our y-axis was? Did it show us anything? No. But now we can plug in some values and we should be able to come up with what we need to. So let's create a t-chart. Okay, so we're going to create a t-chart. So we're going to plug in some values. Whoops, I forgot to move that. So we're going to plug in some values for x and we're going to spit out y. Because the denominator is a 2, I want things that'll be easier to do too. So I'm going to do negative 2, 0, and 2. And then I'm going to spit out for y. Take a minute, pause the tape, and I want you to plug into that equation and tell me what y is. Okay, welcome back. I'm going to show you what the answers were. When you plug in negative 2, you get a positive 3. When you plug in 0, you get 0. And when you plug in positive 2, you get a negative 3. So our points are negative 2, 3, 0, 0, and 2, negative 3. Now, I don't have a graph on here to actually graph this. So we're just going to kind of eyeball it a little bit. So here's our y-axis. Here's our x-axis. And so if we start with the origin, because that is one of the points, 0, 0. Let's see, 1, 2, 3. 1, 2, 3. So now we're going to finish plotting. So then we have positive 2, negative 3. So positive 2, negative 3. And then the next one is going to be negative 2, positive 3. Then we just connect the dots. And sometimes you may have to make your dot a little bit bigger to hit your line. And so that is our ordered pair, and that's our line. Now can you tell me where it crossed the y-axis? At the origin. Very good. Okay, this is an applied problem. Again, it's a word problem. So let's read it. The cost C in dollars of shipping a FedEx Priority overnight package weighing 1 pound or more, a distance of 1,001 to 1,400 miles, is given by C equals 2.8 times W plus 21.05, where W is the package's weight in pounds. It says to graph the equation, then use the graph to estimate the cost of shipping a 10.5 pound package. So we create a chart, and if we let W equals some number, so we're going to choose 2, 4, and 8, and then we're going to see what C would come out. Now remember, W is our weight, so we're looking for 2 pounds, 4 pounds, 8 pounds. And then C is what the cost would be. So if a package weighed 2 pounds, the cost would be $26.65. If a package weighed 4 pounds, it would be $32.25. And if a package weighed 8 pounds, it's $43.45. So the next thing we do is we're going to plot the points. And if you see the green line, it goes through the points that we plotted, and we're going to estimate a 10.5 pound package. So as we locate the point on the line that is above 10.5 pounds. And that's, again, remember the weight was what we graphed first, so it's going to be what we would consider our x-axis. So 10.5 pounds would be somewhere in here. And then we're going to go up till we run into the graphed line and see if we can come up with about what the cost would be. And it's greater than $50, so they just estimated it to $51. That's it for this lesson.